Check one. Check one. Check one. Right. Hello, everybody. Back again with our power and energy online session. Power and energy online session. Already day one session is over. Already the day one session is over. So today we are to continue with our day two session. Right? The day two session. There are things to read and some small are there. That's it. Today's two session. In case if anyone is watching YouTube, please watch the day one session and then watch the day two session. Right, before we start, confirm me from your end, is the video clear and the audio clear? Yes, both are clear, right? I'll go to the YouTube and check. Right, that's also perfect. Day one we complete until calculation on kilowatt hour. Can remember converting joules to kilowatt hour. After there we did last class. And then we learned if they give the power in watt and time in hours, how to calculate the electrical energy in kilowatt hour. And then we did some questions as well. We did questions as well. Yes, we did up to this question, up to this, up to there, we did last class. Today, only some logical parts are there. No any calculation part. Only some logical parts are there. Starting off with, starting off with efficiency. Efficiency of a electrical appliance. Very important section. Efficiency of electrical appliance. Camera angle is not right. Sorry. Hopefully now okay. Maximum try, maximum adjust it. Hopefully now okay. Sorry. Right. Efficiency. Efficiency of an electrical appliance. What is this efficiency of an electrical appliance means? Listen, now if you take a electrical appliance, I'll take a electrical appliance. Now we'll take a TV. This is a television. So an electrical appliance, we input some energy. What's the input energy we give to an electric appliance? What's the input energy we give to an electric appliance? Last week we talked about it. Input energy is always electrical energy. I'll write it fully. Input is electric energy. Electric energy is given as the input. Let's take, I am giving 100 joules of electric energy as the input energy. I am giving 100 joules of electric energy as the input. Now, from the TV, we are going to get some output. What is the expected output from a TV? What we expect from a TV? We expect light. From that only you can see the screen. And we expect sound. Light and sound energy are the output energy. Light and sound energy are the output energy. Now the question is, will all these 100 joules of input energy be converted into direct useful output energy? Will all these 100 joules of input energy be converted into useful output energy? Our useful output energy is light and sound. Will all these 100 joules be converted into light and sound? All the 100 energy won't be converted into light and sound only. Light and sound is the expected output energy. That is the required output energy. We won't get all the 100 joules of input energy as direct expected output energy. Maybe 60 joules will come as useful output energy. Out of 100 joules we input, maybe 60 joules comes as useful output energy. 60 joules comes as light and sound. What happens to the remaining 40 joules? What happens to the remaining 40 joules? Onnalamai, remaining 40 joules of energy will be given out as heat energy. Remaining 40 joules of energy given out as heat energy. Y'all tell me, do we expect heat energy from a TV? Is it the expected energy from a TV? Are we going to expect heat from TV? Are you going to fry eggs on a TV? No. Our expected output is light and sound. That is our expected output. All the input is not converted into expected output. It is converted into some unexpected output as well. Heat is not expected. We don't want heat from a TV. We can get it from a gas cooker. Heat is not needed from a TV. But when it is working, when an electrical appliance is working, a part of the input energy will be dissipated out as heat energy. It's a requirement or it's a loss? This heat output is a required energy or it's a loss? Everyone. It's a required energy or it's a loss? Heat from TV. Required or loss? It's a
loss.
it's a
Yes.
It's a loss. It's a big loss. We don't want heat energy from a TV, but we get it. It's a loss. Harini, once when the TV works and finishes, you just touch We don't want energy, but we get it. It's a loss. We don't want that from a TV. But once then the TV works and finishes, you touch the TV behind and see. You can see heat. It's a loss. Once then you use your phone, what happened? Phone get heated. It's a required energy or a loss. Do we expect heat from a phone? No. It's a loss. Use your laptop, use your computer, touch it and see now. Can you feel the heat? Do we expect heat from your laptop, from your TV, from your computer? No, it's a loss. So heat from electric appliance is a loss. It's an unexpected energy. These are the expected energies. This is unexpected energy. It's a loss. Now listen. If the loss increases, we tell efficiency of that appliance decrease. If the loss increase, efficiency decrease. Ehenang tell me, we try to increase the loss or decrease the loss when we make electric appliance. We try to increase the loss. Decrease. We try to decrease the loss. We are trying to decrease the loss. What we are trying to do to the efficiency?
Increase the efficiency.
We try to increase the efficiency. When you go and buy electric appliance, you all tell me, you should buy a low efficient electric appliance or high efficient electric appliance?
High efficient.
What do you mean by high efficient electric appliance? What do you mean by high efficient electric appliance? Your input energy, huge amount of input energy is converted into useful output energy, not into loss. You may ask me, sir, is heat energy the only loss? No. Loss can be any form of energy, mainly heat energy. It can be any form of energy. Now, for example, sometimes when the TV is working, you might hear an unnecessary sound from it, a noise kind of a sound, kind of a sound. Is it a required energy or a loss?
Loss.
So loss doesn't always need to be heat energy. It can be anything that is not expected. That is not expected. From a driller, what we need? We send electric energy, maximum it should be converted into what? Kinetic energy. Sometimes you can hear a sound from it. Do we need a sound from a driller?
No.
It's a loss. It's a loss. So any electric appliance, when it is working, there will be a certain amount of loss. Maybe heat energy, maybe sound energy, maybe some other sort of energy, maybe even light energy. Even there can be light loss. There can be a light loss source from some electrical appliances. Due to heating, there can be a light loss. So any unexpected energy loss is a loss. When the loss increases, efficiency decreases. So when we go to buy an electric appliance, we should buy an electric appliance with a higher efficiency. That means the loss should be less. So when the loss is less, useful output will be high or low?
High.
Useful
High.
output.
High.
So we should try maximum to increase the useful output. Usually this efficiency is given as a percentage. This efficiency is given as a percentage. How do we write it as a percentage? Now see, to an electric appliance, you are giving an input of 100% of energy. Harina input is always 100%. We don't keep a part of the input and give inside. No, input is always 100%. So you are giving 100% as the input. You give your full as the input. From that full, let's take only 60% is coming as useful output. Only 60% is coming out as useful output. Only 60% is coming out as useful output. Ehenang, there is a loss. What is the percentage of the loss? From 100%, 60% is useful
40%.
output. Then loss percentage is how much?
40%.
Now, if they ask you for the efficiency of this appliance, if they ask you for the efficiency of this appliance, you tell the loss or you tell the useful output? You have to tell the useful output. So what's the efficiency here? 60% is the efficiency. 60% is the efficiency. What do you mean by 60% efficiency? From 100% input, 60% can be obtained as useful output. From 100% input, 60% can be obtained as useful output. Remaining 40 is a loss. 60% is useful output. Now your turn. Now your turn. There is a fan. This is a fan. Of course, you are giving an input of 100% of electric energy. It is dissipating heat. Fan is dissipating heat. When you touch the back cover, you can feel heat. That percentage is 25%. 25% is given out as heat. Ehang, tell me what's the efficiency?
75%.
75%.
Then guaranteed useful output is going to be 75%. That 75% is the efficiency of this fan. You are giving 100% input, giving 25% as heat, which we don't expect from a fan. Efficiency is only 75. Another fan, let's take it as fan B. This is fan A. To fan B, again, your input is 100%. It's producing heat and sound as additional energy. Let's take the percentage of heat and sound, 35%. That is heat and sound. Sometimes from fans you can hear a sound. Now here also this fan is making sound. I don't want that. I don't expect sound from the fan. Ehenang, tell me what is the efficiency of fan?
65%. Useful efficient.
65%.
The balance is 65%. The efficiency is 65. Ehenang, tell me if you go to buy fan, I am showing you all fan A and I am showing you all fan B. Now I am the showroom person. Right? Welcome, ma'am. And I am showing you all fan A and fan B. Etokota, tell me which fan you are going to buy. Fan
Fan
A. Fan A.
Fan A.
You have to buy fan A. Why? What's the reason? What's the scientific reason? Efficiency of fan A is higher than
Efficiency is increased and the loss is decreased.
efficiency of fan A is higher than efficiency of fan B. Not only fan, any electric appliance you go and buy, there will be a separate label. They will show you. They will have written there what's the energy required, what's the useful output energy, input voltage, output voltage, current type DC, the AC, the plus efficiency percentage. You read that 10 by. Now what do our people do? When they go to buy a fan, showroom person will show about 5 fans. You tell to switch on all the fans. All fans are working. Maybe all will give the same amount of wind. All again same amount of wind. Next, what we check for? Color. Do you have the blue color from it? Can I get the black? How many V choice fans? Oh, that's not the correct scientific method of choosing. Scientific method of choosing something is not based on color. It's based on the efficiency. And maybe you can check the power input, power output, energy input, energy output, AC, the DC. Those are the things you have to check. Maybe all will work with the same speed. Fan A also works with the same speed. Let's take the output electrical energies. Let's take 2000 joules from how much? I'm not checking the percentage. Don't check the percentage. Just check the numbers. Output useful energy is 2000 joules. Input energy is 3000 joules. And heat loss is 1000 joules. That is fan A. Fan B, it needs an input of 5000 joules. Useful output, I'm just talking about the energy only. Don't look at the percentage. Output is same 3000 joules. Here 2000 joules. Now look at fan A and fan B. Here I need Yeah, I need 2000 joules. Yeah, let's make it 4500 joules. Here we'll make it 1500 joules. Now look at fan A and fan B. Fan A and fan B. Fan A.
So the percentage of
Useful
So it
output.
should be
1000.
2500
Yes,
for the
sir.
B.
In fan shortage.
2500 for the loss
So
joules.
there's 1,000 missing.
1000 says 1000.
1000 missing.
Now look at fan A and fan B. See? Fan A output is 2000 joules. Fan B output is 2000 joules. Both output is 2000 joules. Both are giving the same wind. Look at the input. B is consuming 3500 as the input. A is consuming only 3000 as the input. See, even though the output is the same, even though how much of wind energy you get is the same, even though how much of kinetic energy generated is the same, input can vary. That's why it's told to check these numbers. Why? When these numbers change, the overall power will change. You all tell me, when the power changes, electrical consumption will change. Electrical energy consumed will change. When electrical energy consumed change, kilowatt hour in your house will change. When kilowatt hour change, your electricity bill will
Increase.
you can basically reduce your electricity if you buy things scientifically, not based on color. Right? So what's the learning from this? When you go to buy things, you should check for higher efficient, low loss electric appliance. Is efficiency means how much of useful output energy you get from the given input. This useful output energy will be higher when you go to buy a electric appliance. So when you're using an electric appliance, which means loss should be less. Now I know the next question you're asking. Sir, electric iron, electric oven, they are used. Don't we have a loss there? You all tell me. In a iron, don't we have a loss?
We have. We do.
We have.
We have a loss. How? See,
The heat.
in a iron, in an electric iron, now this is just one example, one example scenario. In an electric iron, where do you want the heat? You want the heat at the bottom metal plate. You only want at the bottom metal plate to get heated. It should spread only at the bottom metal plate. You all tell me, is it the only thing happening? Don't you
No.
feel heat on
No.
the iron box? Maybe on the handle as well. Don't you feel the heat?
Yes, sir.
Yes, sir.
Yes, sir.
We
Maybe
feel the heat.
internal circuit. Yes.
Yeah.
Is it a required heat? Do we need
No.
heat at these places?
No.
Also the internal parts of that
Internal
iron.
part. So that is what? Use the loss.
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 Becomes
Loss.
a loss. That becomes a loss. So remember, there are loss even in electric kind. Okay. Now you all tell me, when an electric appliance get heated, its efficiency will increase the decrease.
Decrease.
Decrease. So you should try to make electric appliance get heated, or you should try to reduce the heat.
Reduce.
We should try to reduce the heat
Try to reduce the
loss.
That's why have you seen in computers, in the CPU, you have a cooling fan.
Fan.
Sometimes laptops, you may keep it in a cooling pad to cool it, to remove the heat. iPhone 17, the key feature in iPhone 17 is what? Its chip is cooled by water.
3 camera.
Inside iPhone 17, you have water. Not a lot amount. Now, water, not the water you drink, it's ionized water. Ionized water is circulating around the chip. So when the chip get heated, the biggest problem that iPhone came up is it get heated. On Android users, the biggest key point they catch to put down iPhone use is what? Phone get heated. Now iPhone came up with the idea to reduce the heat. How? In their chip, there is ionized water. That ionized water is circulating. So it is circulating. When the chip get heated, it absorbs that heat. Basically, that's latent heat. It absorbs latent heat of vaporization. Water becomes water vapor, goes around the chamber, circulates. From there, removes the heat to the aluminium body, removes it, and that water cools down, comes back, circulates. Again, circulation is happening. So there are different methods used to reduce the heat. For y'all just search about how servers are cooled. Just later on and not now. Just search. I'm not going to explain that. It will take a long time. How mainly this Google server, Microsoft servers, how they are cooled. Later on, search and see. Not now. Later on, search and see. How Microsoft servers they are cooled. Efficiency of electric appliance. When an electric appliance functions, electrical energy is also converted to some other form of energy than what is expected. This is a loss in the energy. When such a loss is less, efficiency of the appliance is more. That's a big problem with the angle. Efficiency is more. Now they are given different types of bulbs for us to compare their power and their lifetime. And we can come to a conclusion about efficiency. We'll try to make a conclusion about efficiency. Filament bulb. What is filament bulb? Or a glass bulb is there, Lamai. At the center you have a filament. That's filament bulb. Fluorescent bulbs are there. Usually they come as tube bulb. CFL bulb is there. Or a white color one. LED ones are there. LED all no. We'll compare them. Filament bulb, their power consumption is 60 watt. Fluorescent, 22 watt. CFL, 11 to 13 watt. LED, 6 to 8 watt. That's their power. Y'all tell me, when you go to buy, you have to buy an electric appliance, low power, the high power.
Low power.
Low.
Power should be low. So power-wise, LED takes first position, lowest power. Even look at the lifetime. Lifetime means how long it can work. Filament bulb, only 1200 hours. Fluorescent tube, 3000 hours. CFL, 8000 hours. Look at LED, 50,000 hours. Fluorescent or a glass bulb, very quickly, its filament get burnt off. I don't know whether you all have it in your houses. If you have, every 3 months at least you have to replace it. Why? Filament burns off. Why? Its lifetime is short. Ehenang, tell me, when you are buying, you should buy with lower lifetime or higher lifetime.
Higher lifetime.
Higher lifetime.
But considering all those features, which one is the best lighting source?
LED.
lights.
LED. Why? Lowest power, longest lifetime. Lowest power, longest lifetime. Which means basically its efficiency is also high. Right? If you fix this bulbs to your houses, guarantee your electricity bill will reduce. If you are using filament bulbs, guaranteed your electricity bill is very high. And fluorescent CFL average. Hence, LED is more efficient lighting source. Example 2. Efficiency of cookers used to prepare food are different from one to another due to varying amount of heat wastage. Now we'll talk about cookers. Old cookers that use heating coils are the lowest in efficiency. While am I the ones that has heating coil are lowest in efficiency? See, the coil get heated by electricity. Now here we are only talking about electrically powered cookers, not gas cookers. So coil get heated. On top of the coil, you keep your cooking vessel. So first coil get heated. coil get heated, that heat is transferred into your food. Will all the heat in the coil be transferred?
No.
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 And even if it is transferred, does all the heat be given only to the food?
No.
No.
A part will be absorbed by the vessel as well. So double loss is there. All the heat in the coil won't go to the food. Even if it goes, it is absorbed by the vessel. Big loss is there. So heating coil ones are lowest in efficiency. Immersion heater is highly efficient for heating water. What's the reason? Directly put the coil inside the water.
Water.
Coil is directly inside the water. So all the heat is directly transferred to whom? Water. Loss is high or less?
Less.
Yes.
Less.
So they are high. The reason is that all the heat generated in the heater is transferred to the water when using it. Heaters which contain hot plates such as rice cookers are more efficient because heat loss is less in them. Now rice cookers, directly they have a hot plate. Directly they have a hot plate. What do the hot plate do? Hot plate using magnetism. Using magnetism, it transfers the heat inside. Using magnetism, it transfers the heat inside. Here, heat is directly given to the food line, not to the vessel, not to the vessel, not to the vessel. If you have induction coil heaters in your house, those who have, you all tell me, when you cook using induction coil, does the vessel get heated? No. Those who have, they know. Vessel doesn't get heated. What get heated? Directly the food. So directly we are sending the heat where it is needed. We don't need the heat to the vessel. Although microwave ovens cannot be used to cook all type of food, they are very efficient since they produce heat inside the food item. Can you remember the working mechanism of a microwave oven?
Yes.
We learned
Yes.
it in waves lesson. How does it work?
Magnet.
Microwaves are directly sent to your food. Once when the
Inside there will be
microwave is
two
sent to
coils
the food,
that generate
I'll
the
explain.
heat.
Once when the microwave is sent to the food, in the food, water molecules and fats will vibrate. When they vibrate, they rub against each other. When two things rub against each other, they guaranteed produce what?
Heat.
We are directly vibrating the water and fat in the food, not the vessel. Heat is not given from outside. In the food, water and fats are vibrated, rubbed, and you produce heat. Highly efficient. Very efficient to produce food. In addition to these, induction cookers with high efficiencies are now available in the market. In these devices, the variable magnetic field emitted by cooker generates heat only at the bottom of the cooking vessel. Next, coming into TV. TV. You all have a box ones. What is that box one called as in ICT you all learned? CRT monitors. You all have it in ICT.
Yes.
Cathode ray tube. CRT monitors are box ones. And you have LCD. Liquid crystal display.
Liquid.
And you have the LED.
Liquid.
Light emitting diode.
Light emitting diode.
Light emitting diode.
Which one consumes lowest electric energy?
LED.
LED.
No.
Light emitting diode.
Dynamic diode.
LED ones are the lowest. Second is LCD.
LED.
Ammi, CRT. CRT is a beast. Consumes a lot of electricity. So if you are using a TV in your house, best option is go for LCD or LED. Not CRT.
LED.
No.
LED.
No, I'm telling best option is go for either one of this. Don't go for CRT. CRT is a big beast. It consumes a lot of energy compared to LCD and LED. Even compared to LCD and LED, LED lowest. This is what is there in our syllabus. But actually now there are so many ways. Just go to the Samsung company and check for the LED, check for the flat screen TV. I don't think now there are LCD ones. There is UHD. Even different ones are there. I also don't know how they function. I have to research about it. So many different screens have come now, right? You all can research about. Huh? The power consumption of television set that uses LCD screen is lower than that of the television that uses cathode ray tube, CRT. LCD television sets that use LED lights to illuminate the screen have the very low power consumption, and they are known as LED television in the market. Fans on. What fan is better, Lamai? The hanging one or the table one?
Table.
Hanging
Table.
fan
Table.
or the table one?
Table.
Table.
Fan.
Why? Hanging one is holding a certain weight. It's hanging. A big weight is hanging. So that weight has to be rotated. Now you are thinking motor is rotating a fan. No, that's not the logic there. Motor is actually rotating a load. That's the correct science there. How does the motor work? Motor doesn't rotate a fan. Motor is rotating a load. What we tell is the load there. So a load is rotated. If it is hanging, load is high. If it is fixed this way, most of the time table fans are plastic. The plastic turbines are there. Even metal ones are there, but not as heavy as the wings of the hanging ones. So here weight is very low. Load is less. Load is less means energy output is high. Here high energy should be given as the output. So compared to the hanging one, best is table fan. Now don't ask me, sir, then the other one, stand fan, table fan, almost the same category, almost the same category, right? So at night, if you are using fan, if you have a ceiling fan, because if you have a table fan, which of the ceiling fan, table fan, best of, you can reduce your current. Similarly, now you might be telling, no, sir, I have enough money. I can pay for the power. You learn science for the not for the money. You should try maximum to reduce the energy consumption, because if you create a loss, now if you have the ability to reduce the loss, you have to do it, not money. You talk in terms of energy resource we have. Otherwise, energy. One by one, everyone in our house should do this. We should try maximum to reduce the loss in our houses. Otherwise, we'll have to face a huge energy crisis in the future. Similarly, it is more efficient to use table fans to cool houses than ceiling fans. Using the most efficient device suitable for a particular purpose whenever possible would help to minimize the future energy crisis. Last one. So what about AC? Now, if you really want to go for AC, there are inverter AC, non-inverter AC. You check which one consumes lowest power and you go for that option. If 40% of energy supply to a certain electric appliance is lost as heat, then only 60% of energy would be used for the expected purpose. This means that the efficiency of the electric appliance is 60%. We should try to minimize the loss of electric energy as heat and get the maximum out of the electric energy supplied to a particular purpose. Ironing all clothes required for a week in one occasion is more efficient. Now, when you're ironing, what do you do? Monday night, then only we start washing our uniform. Friday you were at home. Saturday you were at home. Sunday you were at home. Monday night only we take the Friday's tiffin box, wash it. We take the uniform, socks, wash it. Then we put it in front of our fan and dry it. Early morning Monday we wake up and start ironing it. Same schedule on Tuesday. And those socks will be hanging in front of the fan. No. When you're ironing, what you should do? You collect all the clothes and you iron at once. Why? Every time you switch on the iron, you have to wait for about 10 minutes for it to initially get heated. Our initial heating process is there. No? Just after you plug in the iron, you can't take it and iron. You have to plug it, wait for 10 minutes until it gets initially heated. So every time you switch it off and switch it on, you have to wait for 10 minutes for its initial heating. It's a loss. So if you iron all the clothes at once you give some time for its initial heating and then you can use it. Ironing all clothes required for a week in one occasion is more efficient because it saves electricity used in initial heating of the iron. All the unwanted lights of the home should be switched off. Also, they have to use more efficient such as CFL or LED bulbs. හරි නේද? Will these points come for the exams? Maybe they will give some power values for some electric appliance and ask you which one has the highest efficiency. Just like I told you to select from LED, CFL, fluorescent, such a question will come. That kind of a question will only come. Or they will give percentages. 100% input is given, 40% loss, 60%. That kind of a question will only come. Hurry, right. Next, last part of the lesson. Home electric circuit. Home electric circuit. Now we know in Sri Lanka, electricity is generated in power stations. Electricity is generated in power stations. Tell me some power stations from where electricity is generated in Sri Lanka. Hydro, coal power station, coal power station.
Wind power station.
Wind power station is there.
hydropower station.
Hydropower station. We mainly have hydropower station, Victoria, Kothmale, Rantambe, Randenegala. Those places we have hydropower station. And we have wind power station, Hambantota Puttalam wind power station. And we have fuel power station. Kalanith is a fuel power station. Coal power
Mainly
station.
island areas, sir.
Nuracholai coal power station is there. Solar power station is not there in Sri Lanka. We don't have a separate power station called solar power station. But what we can do is to our houses, we can fix solar, and whatever the electricity we generate, we supply to the government. We can't use it. There is a rule in Sri Lanka that not only Sri Lanka, any country, whatever the sun's rays that fall onto that country belongs to the government, not to you. Whatever the sun's rays that falls on top of your house, it doesn't belong to you. It belongs to the government. It's a rule, eh? It belongs to the government. So if you now let's say you are fixing solar panels on top of your houses, whatever the electricity you are generating, you can't use it. You generate and you give it to the government. They will supply electricity for your house. They will how much you have given, how much they have supplied. That they will cut off. That's the logic of fixing solar panels. And we don't have separate solar power stations in Sri Lanka up to date. Maybe later on we'll. Nuclear power station, we don't still have it. We don't still have it. Maybe in later we might have. It's a very high technology. Geothermal possible in Sri Lanka, but we don't have geothermal as well. Floating power stations are not there. Those technologies are not there. Those are not there, right? So we have hydropower station, coal power station, wind power station, and fuel power station. Those are the main power stations we have in Sri Lanka, right? So electricity is
Don't we
produced
have
in.
solar power station? So
I'll
I
come to
mean
the
like
doubts,
solar
Pratap.
farms.
Let me explain. So we have power station. From power station, electricity is generated. From those power stations, finally, in your house, through your plug points or through your bulbs, through your plugs, and through your bulbs, you get the electricity. Electricity is generated in power station. It comes to your plugs and bulbs in your house. How does it come? What is the journey there? How does the electricity produced in the power station come to the bulbs, come to the plugs? Right. Listen, listen very carefully. Don't go to memorize this. Understand the logic here. Now we have different power stations. All these power stations, once when they produce the electricity, they will send the electricity to a central hub. Hydropower station, coal power station, fuel power station, wind power station, and from houses, solar power station. They all send the electricity to a final central hub. That central hub is called as national power grid. National power grid. Now you can think like national power grid is like a control unit. They get the power from hydro, power from coal, power from wind, power from solar. Power from what did I mean? Coal. All come to the national power grid. Don't think directly from hydropower you get the current to your house. Nay, hema nevi lama. Electricity should be balanced. According to demand only
Okay.
you send the supply. So direct from the power station you can't send supply. All will give the supply first to the central hub, national power grid.
This
National power grid will
fine.
check whether the supply is high, whether the demand is high or low. Accordingly, they will balance the electricity and they will send it. And don't think all these power stations will be functioning at the same time. Nah. During rainy season, mainly hydropower station takes the turn. During monsoon, mainly wind power station takes the turn. Other time, we balance using coal and fuel. There's no wind, no rain. Then mainly coal, Nurachole, and Kalanith is the fuel. They take for the turn. So whatever we don't get from the natural resource, then we fill it by the coal and the fuel, right? And there's a big process. Now, usually from 7 p.m. to 9 p.m. is the highest demand of electrical in Sri Lanka. So at that time, mainly coal fuel will be working. They will be working at a high capacity. And unnecessary time, they have to switch it off. They switch off that power station. Once when a power station is off, next one will be on and they connect it and supply it. That much of a controlling should be done. But we don't get any power outrages, no? Without any loss, they switch off a power station, connect the other power station and send the current without any loss. Sometimes, now let's take hydro is switched off at 5. They shut down hydro at 5. It's not it's a big shutdown. Hydro is shut off at 5. Then at 5, Nurachole should also be switched on, let's take. In case, if the switch on didn't work, there is a technical issue there. Or the shutdown didn't work, there's a technical issue there. There will be an island-wide power cut. Sometimes we get island-wide power cut. That's the reason. One off, one on didn't happen on time. Right? You will tell answer, then quickly we can switch on the other one. No. It's a big process. They have to balance the power quickly. The demand will increase. You supply that high demand at once. So they have to balance the power and only they have to send it. All those balancing is done by national power grid. The power station will supply the electricity first to the national power grid. What will the national power grid do? According to the demand. According to the demand. Now, not all the provinces have the same demand. Colombo, they have high demand. I'm just telling an example. Colombo has a high demand. But if you take another province, like let's take Anuradhapura, demand is low. Why? Colombo, the most populated district in Sri Lanka. So demand is high. Anuradhapura population is less. So demand is less there. So according to the demand, they will balance and they will supply it. How do they supply? They have to increase the voltage and supply. Whenever when you are sending current to a long distance, you have to increase the voltage. Why? You will learn it in current. You will learn it in electromagnetic induction lesson. In that lesson, I teach you all why we are sending why when we are sending electricity to a long distance, we increase the voltage. So here we have to send it to a long distance from national power grid. Long distance transformation is happening to the electrical energy. So you increase the voltage using step up transformer. You can increase voltage. Using step up transformer, you can increase voltage. Usually it's increased to 132 kilovolt or 220 kilovolt and sent. Sent where? Directly to your house. No, you can't send this much of high voltage electricity directly to your house. First it is sent into distribution subcenters. First sent to distribution subcenters. You might have seen in your areas, there will be small electrical subcenters. That's a distribution subcenter. So from the national power grid, first the current is applied to the distribution subcenters. If you check your electricity bill, they will mention what is your distribution subcenter. It will be mentioned. What will distribution subcenter do? They will furthermore reduce the voltage. Again using step down transformer. You won't understand about step down transformer now. That also comes in electromagnetism, induction lesson. Using step down transformer, they furthermore reduce the voltage to 11 kilovolt or 33 kilovolt. Send it to your transformers near your houses. Have you seen in your road? Sometimes there will be a green color big box in your road where all the
Box,
wires
right?
come and connect there. That's a transformer in your road or your street transformer. So from there, electricity is sent to the transformer in your street. It will furthermore reduce the electricity and it comes through distribution wire or the distribution cable. What is this distribution wire means? When you go out Lamai, you would have seen on your streets, if you check the electricity post, there will be 3 wires going like this. Have you seen?
Yes.
Yes.
Yes, sir.
That's
Yes, sir.
distribution wire. That's distribution wire. A certain gap is maintained between them. They are mounted on ceramic shields. So many things are there. Later on, after O levels, you all research about it. Why they are mounted on ceramic shield and why the ceramic shield have a shape like this. This kind of shape. Mehema shape is there. I can draw it like this. This kind of a shape is there for the ceramic shield. Why that kind of a shape is there for ceramic shield? All those things later after O level, you all research about it. Superb sections. So this is distribution wire. So that current comes to distribution wire, or even you call it distribution cable. From distribution wire, next the current is supplied into supply cable. Supply cable, or even you call it the service cable. Supply cable. What is that supply cable mean? Let's take this is your house. Have you seen from this main wire, another separate wire is coming to your meter box? I don't know, from here current should come to your house. No? A separate wire comes to your meter box. That wire is service cable or the supply cable. That's a service cable or supply cable. By the time current comes to the supply cable, now the voltage is about 230 volt. Ehinang, tell me in Sri Lanka, what's the voltage supplied to the houses? 230 volt. AC the DC the. Using your electronics knowledge, tell me AC the DC the. AC. Domestic electricity supply is AC. AC current 230 volt with 50 hertz of frequency sent. 50 hertz of frequency. What do you mean by 50 hertz of frequency? AC current. AC current has a waveform like this. This wave will have a certain frequency. What's the frequency? 50 hertz. What do you mean by 50 hertz? I taught in electronics. What do you mean by 50 hertz? In 1 second, how many waves are there?
50.
50 waves are there. 1 second, 50 waves is 50 hertz. 1 second, 50 waves is 50 hertz. So in 1 second, there will be 50 waves, that is 50 hertz. 230 volt AC current of 50 hertz frequency is supplied to your houses through supply cable. Now, first, where does this electricity go? Listen, first, where does this electricity go? From the supply cable, now it comes to overload circuit breaker. It goes to overload circuit breaker. What is this overload circuit breaker means? If you check your meter box, there you have the electric meter, but before the electric meter, another small switch is there. Maybe a fuse or a switch is there. That switch is overload circuit breaker. So first the current goes to the overload circuit breaker. First to the overload circuit breaker. From the overload circuit breaker, next to electricity meter. Electricity meter. I'll tell about their function separately. First understand the flow. Electricity meter. Electricity meter. This electricity meter and overload circuit breaker, even though they are in your house, even though they are in your house, they do not belong to you. Let's say there's a small repair there. You are hearing unnecessary sound. Can you go and check there? Where we'll see what has happened? Can we go and remove and see there? No. You can't do any changes to what is inside the meter box. That's electricity meter and overload circuit breaker. You can't do any changes. But at an emergency, yes, you can switch off your overload circuit breaker. Emergency, switch on, switch off, you can do. Repairs, you can't go and do. So if you have to repair, let's say there is a fire. There is a spark generated from there, your meter box got fired. Then what you have to do? You have to call your electricity supplier, bring them and get it repaired. Let's say you are electrician. Even if you are electrician, you can't go and repair it. You can't go and repair it. You have to bring the electricity supplier and then get it repaired. It doesn't belong to the consumer. It belongs to the electricity supplier. What belongs to the electricity supplier? Open the mouth and tell. Electric meter, overload circuit breaker. One more time. Electric meter, overload circuit breaker. Don't ask me, sir, what about the supply cable, distribution, or lamayo? However, those things doesn't belong to you. No, you can't touch them. Even though these things are inside your house, you can't even touch it. You know, electric meter and overload circuit breaker, you can't touch it. It doesn't belong to you, right? After this, now electricity is supplied inside your house. It comes to your house. Electricity meter will measure how much you are using. From there, electricity comes into your house. Now, in your house, have you all seen somewhere a big box like this? When you open it, there is first a switch, double switch is there. Maybe two switches are together. You can put it up, put it down. And then another separate switch is there. Nearby that a button is there. I'll show you all pictures. And then so many cute little switches are there. A double switch. One single switch is a button. Cute little switches are there. The first switch is called the isolator. Second one with the button is residual current circuit breaker. Open the mouth and tell. Residual current circuit breaker. Short form RCCB. RCB nevi, Royal Challengers Bangalore nevi. Residual current circuit breaker. RCCB. Also you call it, hearts are coming. RCB fans are now sending hearts. Also you call it trip switch. Trip switch. Also you call it trip switch. After that, small switches are there. These small switches are called as all of them. Miniature, small ones, no? Miniature circuit breaker. Miniature circuit breaker. You call it MCB. You call it MCB. Isolator, residual current circuit breaker, RCCB, trip switch. Then miniature circuit breaker, MCB. Go tell me, isolator, residual current circuit breaker, miniature circuit breaker. So current also flows in the same way. First it goes from electricity meter to the isolator, from isolator to residual current circuit breaker, your trip switch, from residual current circuit breaker to miniature circuit breaker MCB. From miniature circuit breaker only, current comes to all your plugs and bulbs and whatever the electric appliance you are using. So look at the full path. From a station to the national power grid. National power grid increases the voltage to 132 kilovolt or 220 kilovolt using a step-up transformer and sends it through distribution, sends it to distribution subcenter. Distribution subcenter will reduce the voltage to 11 kilovolt or 33 kilovolt and send it through distribution wire to supply cable. Supply cable gives the current to your house. 230 volt AC with 50 Hz frequency supplied. First in your house, current is sent into the overload circuit breaker and then electricity meter. Both overload circuit breaker and electricity meter doesn't belong to the consumer. It belongs to the electricity supplier. From there, current comes inside your house. First the isolator, first switch, next RCCB button switch, next MCB Q2 ones, then plugs and bulbs. So tell me the flow chart. Power station, national power grid. Increase the voltage to 132 kilovolt or 220 kilovolt. Then distribution subcenter. It reduces the voltage to 11 or 33. These two easy to memorize. 11 multiplication table. 11 and 33 kilovolt. Then it goes through distribution wire, 3 wires. Then through supply cable or service cable into your house. 230 volt, AC, 50 Hertz. First, into your overload circuit breaker, then electricity meter doesn't belong to you. Next, isolator, RCCB, MCB. One more time. Isolator, RCCB, MCB. One more time. Isolator, RCCB, MCB. Then plugs and bulbs. Okay. Here itself, I'll draw the meter box. That is the what's that? That's the overload circuit breaker. And then you have the electricity meter. Hurry. How many wires bring current to your house? So tell me.
3.
2.
11.
How many wires bring current to your house?
One.
How many wires? Only 2. No, sir, there are 3 wires. No. Lameo third wire is earth wire. It doesn't bring current. It only protects you. Later, I will teach about how it protects. So 2 wires bring current to your house. 2 wires are bringing current. Give me a second.
Sir.
Two wires are bringing current to your house. One is a brown wire. The other is a blue wire. What is this brown wire? Brown is live wire. Blue is
Distribution.
neutral wire.
Original.
Brown is the live wire. Blue is the neutral wire. Some people tell current only flows in live. Current is not flowing in neutral. Some people tell like that. Have reality is this. Lamai, for a current to flow, what should be there? There should be a potential difference. Only if there's a potential difference, there will be a current flow. You all learned it in. If there is potential difference, only current can flow. If there's no potential difference, current won't flow. So for the current to flow in your house, there should be a potential difference. This is how that potential difference is created. Your live wire has a high potential. Neutral is zero potential. Live is high potential. Actually, live is only 230 volt potential. Neutral is what? Zero potential. Live is 230 volt potential. Neutral is 0 volt potential. What's the difference? Adi, 230 0. What's the difference? 230.
230.
That's how we tell a voltage of 230 volt is applied. Live is 230, neutral is 0, gap is 230. That's how we create a potential difference of 230. So actually live is high potential, neutral is 0 potential. Now, this live wire is coming. Live wire first goes inside the overload circuit breaker. Ehema chuti fellow comes out. And then go to the meter box, electricity meter. Neutral wire, it doesn't go to the overload circuit breaker. It directly goes to your electricity meter. Ehenang, tell me what wire is sent inside the overload circuit breaker? Live. Does neutral go inside the overload circuit breaker? No. Only one wire is sent inside overload circuit breaker, only live. Is neutral going? No. Ehenang, tell me, if I disconnect overload circuit breaker, only what time disconnecting?
Live.
Only live.
Live. Only live.
Put by switching off overload circuit breaker, on live connected by overload circuit breaker. Both will go to the meter and both will come out of the meter as well. Of course, they should come. And both will go to the isolator. Both goes to the isolator. There you go. And both will come out of the isolator as well. Ehenang, tell me, if I disconnect isolator, what and what time disconnecting?
Both the live and the
Very important point. And they will ask in the exam. Overload circuit breaker can only disconnect live. Isolator can disconnect both live and
Neutral.
Therefore, isolator is actually called a dual pole circuit breaker. A dual pole or a dual polar circuit breaker. Why dual? Dual means what? What do you mean by dual?
Double.
Two. Dual means two. So both live and neutral can be disconnected by isolator. You call it a dual polar circuit breaker. Is overload circuit breaker dual polar? Is it dipolar? Nah.
No.
From there, this goes into the RCCB. Both go inside the RCCB. Comes out. After that, everything goes inside both. Goes, him it passes through everything and connection comes out. Sorry. So this is your wiring. Live only goes through the circuit breaker, neutral doesn't go through overload circuit breaker. Both go through isolator, RCCB, or the other. That's your connection. Home electric circuit. Electric energy required to operate home electric appliances obtained from national electric grid. Electric energy generated by electric power station are raised to high voltages such as 132 kilovolt or 220 kilovolt. They never have asked these numbers, but just keep it in mind. Using step-up transformer and distributed throughout the island using distribution subcenters, these high voltage are lowered to voltages such as 33 kilovolt or 11 kilovolt, and ultimately they are lowered down to 230 volt before supplying to households. Electricity provided to houses in the form of an AC current, this is important, with a frequency of 50 hertz. Those pictures are given. Distribution wire, supply cable, overload circuit breaker, electricity meter, isolator, RCCBs, miniature circuit breaker, switch plug, earth wire, light bulbs. Electricity is supplied to houses using service cable, that's the supply cable, consists of two wires known as live and neutral. Current flowing through these two wires is provided to electric appliance through a circuit inside the house. See, overload circuit breaker only live. Electricity meter both, isolator both live and neutral. RCB both live and neutral. All the others also both live and neutral. Overload circuit breaker. Now we have to go through each one of their uses. Right. What's the use of an overload circuit breaker? Why you need an overload circuit breaker in your house? Listen, ne? Sometimes the current coming through the supply cable can be a high current. Sometimes at night this happens. Power is not maintained properly because demand is low at night. At night means I'm talking about midnight or early morning, 4 o'clock, 5 o'clock. Current coming may extremely increase because we don't have voltage protectors in our houses unless and otherwise you fix it. If you are buying an electric vehicle, you should guarantee to have a voltage protector in your house. Most of us, we don't fix it. So sometimes voltage is not balanced. It becomes imbalanced. When it is imbalanced, current supply also increases. Let's take a huge current comes. The Dungala overload circuit breaker will go down. Why? Overload circuit breaker allows a maximum current of only 40 amperes to pass through. If a current more than 40 amperes passes, overload circuit breaker, if it has a lever, automatically the lever will fall down. If it has a fuse, fuse will burn off and disconnect the power. Right? If you have a lever, of course, you can go and put it back again. If it is a fuse, you can remove it and you can replace it. If you don't know how to work on it, directly call the power supplier. Electricity is applied to household first passes through the fuse connected to the live cable. This fuse is arranged to allow a passage of maximum current of 40 amperes. If a larger current passes through it, the circuit breaker disconnects power to the house. When this happens, power can be reconnected by moving the lever up manually. In older houses, a fuse is used instead of the circuit breaker. When a current above the limit passes through the fuse, which is made of alloy consisting of lead and tin, it heats up, melts, disconnecting the power supply. The fuse wire is inserted in a ceramic tube or a ceramic mount. This is the lever one, this is the fuse one. It's in a ceramic. You fix it and you can remove. Only the live wire is disconnected by overload circuit breaker. Underline or highlight it. Only the live wire is disconnected by the overload circuit breaker. Another name for overload circuit breaker is service fuse. Second, going to your electricity meter. What does electricity meter do? What's the function of electricity meter? It measures amount of power consumption, the energy consumption. Tell me properly.
Energy consumption.
Energy.
Energy consumption. Can you measure the power consumption by the supply? No. Power consumption is based on the electrical appliance you have. I told you. Appliance decides power, not the meter box. Meter box measures the energy you are consuming. What energy? Electrical energy. In what unit?
Joules.
Not in joules.
Kilowatt.
Not in joules.
Kilowatt hour.
You measure it in kilowatt hour. Domestic electric energy consumption is measured in kilowatt hours. Why? It's a big value. You can't mention it in joules. If you mention it in joules, you get a big value. So you measure it in kilowatt hours. Okay? And accordingly, they bill it. Electricity meter. Somebody read. Raise the hand, those who want to read today. Raise the hand and keep. Keep raising the hand. One by one, then we can give. Hurry. Umar Hashim. Umar Hashim. You can read. Electricity meter. You're reading? Yes. We'll shift to the next one. Aina.
Electricity meter. Consumers are billed according to the amount of electricity they consume. The meter records the electric energy in kilowatt hours. The live and neutral wires coming through the overload circuit breaker or service fuse are next connected to the electricity meter. These two wires coming from the electricity meter are next connected to the main switch. An electricity meter is shown in figure 10.7. Overload circuit breaker and the electricity meter are properties belonging to the service provider. Electricity board or electricity company, and any problem with these items should be solved by informing the service provider. Excuse me,
Sir, you are muted. Sir, you are muted.
If there any problem with that, can you go and repair it? If there is a problem with the overload circuit breaker and electric meter, can you go and touch it? Can you go and repair it?
No.
Those things have to be
No.
done by the service provider. Keep that in mind. Right. Those two done. Now coming inside your house. First going to the isolator. First coming to the isolator. Isolator. It has the connection to both live and neutral, which means it's a dual polar circuit breaker or a dipolar circuit breaker. What's the function of isolator? Let's take a current of more than 30 ampere comes inside your house. A current of more than 30 ampere comes inside your house, isolator will disconnect. Overload circuit breaker will provide protection for 40 ampere current. Isolator provides maximum protection for 30 ampere current. So it won't allow 30 ampere and more to pass inside your house. 40 ampere is given by the power supplier. 30 ampere is accepted by your house. So maximum you can take, it can send 30 ampere current. If a current of more than 30 ampere comes, isolator will disconnect. And it will disconnect only the live and neutral both.
Both.
Live and neutral both. Hurry, isolate. One more point. Now, if you are repairing something in your house, now let's take, there's a problem inside the house in the internal circuit. You are going to repair it. Then, what you switch off? Is it the overload circuit breaker or the isolator?
Isolator.
Isolator. Both live and neutral can be disconnected. Plus, you can't do anything with the overload circuit breaker. No, it's not a property belonging to you, no, Lamai. So you can touch maximum your isolator. So you put your isolator down. Right? Isolator. Who is next? Fatima, you can go ahead.
Isolator or main switch with main fuse. All items in the domestic circuit beyond the isolator belong to the consumer. After passing through the electric meter, the live wire passes through an isolator that allows the passage of a maximum current of 30 ampere. Isolator acts as a 30 ampere high current circuit breaker too. In any instance, by the lowering of the switch levers, it can be disconnected the home hold circuit from power mains L and N. In all the domestic electrical circuits, a main switch consisting of a 30 ampere fuse and a dipole switch was used in the place of the isolator. The isolator is capable of disconnecting both the live and the neutral wires. Such switches are known as dual pole switches. Disconnecting the domestic circuit for any repair purpose can be done by turning off the isolator. Figure 10.8a shows the outward appearance of an isolator, and figure 10.8b shows the circuit diagram of a main switch.
Right, thank you. Underline, highlight the dual pole switch part. It's a dual pole switch. 30 ampere high current circuit breaker. Right. Diagram is also given. Next, RCCB, trip switch. Now, you have seen after the isolator. Now, isolator is a double switch. That's the first switch. Today, go and check your consumer unit. You check your consumer unit. First, there will be a double switch together. You can't turn one up and down. Both will go up together. Both will come down together. Dual polar switch. Both will work together. The first switch is the isolator. Second, you will see something with a button. That is RCCB. You call it the trip switch. What does the trip switch do? What does the trip switch do? Now let's say in your microwave oven, in the internal circuit, some wire broke. And that wire is leaking current to your metal casing. A microwave oven have a metal casing. No? It's leaking current to the metal casing. If you go and touch the microwave oven, your trip switch will fall down. Let's take in the microwave oven, there is a current leak. Go and touch. If you touch, there is high risk of you getting the shock. So to protect you from the shock, which goes down, RCCB. That's the main use of RCCB. It protects the residents from electric leaks and shocks. Okay. Some people tell for lightning also it provides protection. No. We don't have anything in our house that protects us from lightning. Keep that in mind. Lightning protection is not given by trip switch. For that, trip switch should be at a good working condition. When there is a leakage, automatically it should fall down. That happens due to electromagnetism there. That's the magnetism that's happening. From that only switch falls down. Now, how do you know whether your trip switch is working properly or not? Near the trip switch, there is a test button. You go and press it and see. Don't do it now. You go and press it and see. The trip switch should fall down. If it falls, it's working. If it doesn't fall down, it's working. At least once in every 2 weeks, at least once in week, inform everyone in your house and tell them I'm going to check the test trip switch. But informing, don't go to do that. Whether it falls down, whether current get disconnected in your house. It's also a dual polar switch. Who wants to read? Keep raising the hand. Deshan.
Residual current circuit breaker, RCCB or trip switch. After the isolator, the live wire and the neutral wire are connected to a RCCB or a trip switch. The purpose of connecting to a RCCB is to protect the residents from electric shocks. When there is a current leak to the metal carrying of an appliance or to the ground, the circuit is automatically disconnected by the RCCB. The RCCB too is a dual pole switch. outward appearance of a RCCB is shown in figure 10.9 and circuit diagram of a RCCB is shown in figure 10.9.
Right. That is RCCB. Now, leave this part aside. Red part, Euler circuit breaker, meter box, electricity meter, those are not belonging to you. This isolator, RCCB, miniature circuit breaker, all will have a circuit. It's a circuit. From outside only you see switches. From behind there's a circuit. Wires are coming in, wires are connected, wires are going out, wires are connected. There's a big circuit inside. That circuit connection is called as consumer. You call it the distribution. You call it the distribution box. You call it the distribution box. Some people think distribution box is the box that you see. Where you go, you need the box. What you see is just a frame. Ek box නෙවෙයි ළමයි. You remove that. You remove all the switches there. Once you remove all the switches, you can see a big circuit connection behind. That circuit connection is distribution box. From that distribution box only, current is distributed to your house. How it is distributed? See, current now came to the isolator, it passed through the RCCB. Next, the current goes to miniature circuit breaker. Now you will have a lot of miniature circuit breaker, not one, not two. There will be several miniature circuit breaker. What's the function of this miniature circuit breaker? Look, now let's take, you have about 5 miniature circuit breaker. Each miniature circuit breaker is assigned to each part in your house. Maybe the first one is assigned for the hall. All the electric circuits in the hall are connected to the first miniature. Second one is assigned for the kitchen. Third one is assigned for the first room. Next one is assigned for the second room. Next one may be your washroom. Like that, each miniature circuit breaker is assigned for each area in your house. Now let's take in the hall. In the hall to a plug point, you are connecting a multi-socket, and you connect a fan there, phone there, TV there, computers, CPU there, monitor there, everything to one multi-socket. Once you connect lot of appliances to one multi-socket, from one cable you are trying to draw lot of current. From where? From hall. If you try to draw lot of current from one cable, the miniature circuit breaker assigned to that area will fall down. Now you are doing this in the hall. In the hall, miniature circuit breaker falls down. Kitchen, no one will know. Room 1, your father is there, he doesn't know anything. Room 2, your useless sibling is there, doesn't know anything. Washroom, doesn't know. Only the hall, current goes. Have you experienced that? When you go to do any unnecessary things connected to electricity,
Yes, sir.
only to that area, current goes off.
Yes, sir.
Yes, sir.
I have many times come across it. Grade 4, I took a LED. I told to the Vattala people last week. I took a LED, connected directly to the plug point. Got the LED, clipped the pencil to the earth. I hope my mother doesn't watch this video. Clipped it to the earth, connected the LED directly to the plug point. Switched it on. My first wrong. Connected to current. Dongala LED broke. And current went to the hall. Mother doesn't know, father doesn't know, sister doesn't know. Shape went, only one is down. Put it up. Second, there was a wire. What do you call? What wire is that? Take it again. Multi-socket wire is there. Took a knife, cut that wire. Sparks plugged out. Or spark it, I cut that wire. While the current is coming, I cut that wire. Look at the useless things I have done. When I think about those things, no, more a useless fellow I was during that time. Cut that wire to see what happens. That I did in the room, I think. Room. I can remember the wire. However, room. Room current went. At that time, room, no one was there. No one else knows. Shape went. Switched on this thing. Like that, when you go to do some useless things, don't go to do these things. I'm not telling as inspiration for you all. Don't go to do these things. I survived these things. This can even create a big fire. Right? Now I understand it. This can even create a big fire. Don't go to even do it. At that time, only one place MCB falls down. Only one place MCB falls down.
So I did the same thing.
No comment from me. I won't tell good, I won't tell bad. No comment from me. So one place MCB falls down. So when you try to draw large current, usually when you try to draw large current, when there is a situation of fire, when you try to draw large current, lamai. Now let's take to the same cable. You're connecting a fan, you're connecting a phone, you're connecting your fridge, you're connecting the CPU, you are connecting the monitor, everything to one single multi-socket. That means from that one single multi-socket, you are trying to draw a large current. Can large current flow through that wire? No. If such large current flows through that wire will get heated. Fire can occur. To avoid it, your MCB falls down. Even if you put it up, it will fall down. If you want it to work, what you should do? You should remove it from the plug point. Whatever you connected, you remove from the plug point and again switch it on, it will work. That is MCB. And you have two types of wiring in your house. There is lightning circuit. You also call it lamp circuit. And you have plug circuit. Plug circuits are also called switch circuits. Lightning circuit, lamp circuit, plug circuit, switch circuit. Usually in lightning circuit, you can expect a maximum current of 6 ampere. Plug circuit, maximum current of 13 ampere, which means to the plug points, you are getting how much of current? 13 ampere. Now, usually these kinds of 13 ampere plug circuits are connected to your kitchen or washroom. Those places only 13 ampere plug circuits are connected. Because in kitchen, high powered electric appliance can be connected. Oven, fridge. The washroom, maybe washing machine is connected. They need large.
Excuse me, sir. Maybe the
I'll
all
come to the doubts. To the lightning circuit, to the lights, bulbs, you don't need large current. They need about 6 ampere, 5 ampere current. So for them, 5 ampere, 6 ampere current is connected. Ehinam tell me, some people do like this. From the plug point, they try to extend and connect a bulb there. From the plug, a bulb is connected. Is it a correct good work or it's a bad thing?
bad thing.
Not good. Right. So all this distribution are done from the MCB. All these circuits are there connected to what? Connected to your distribution box. Connected to your distribution box. Everything is there in the distribution box. What kind of circuit connection we have in our houses? Series connection, the parallel connection.
Parallel
connection.
Series.
parallel.
Both. So in a doubt, you yourself will answer me now. Let's take your house is wired in series. This is the wire. There is a bulb. This is the bulb going to your kitchen. That wire, you have the fan. This is the fan. Fan in room 1. This series connection, the same wire. You have another bulb. That bulb is in room 2. Let's take parallel connection. Current is coming. Current is coming. I'll draw it in this way. There's a bulb in the kitchen. There is a fan in room 1. There's a bulb in room 2. This series connection. Sorry, that's parallel connection. Just imagine in series connection, kitchen bulb went off. Bulb went off. Burnt off. Current is now not going to the first bulb. Current supply to the first bulb is stopped. Ehenang tell me, will the room fan get the current?
No.
No.
From that point onwards, current flow will be fully stopped. Room fan won't work. Room 2 bulb won't work. Everything will not work. Look at parallel connection. Kitchen bulb went off.
Not.
Will it obstruct the room fan?
No.
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 Current
No.
can go to the room fan. Will it obstruct the room 2 bulb?
No.
No.
Ehenang tell me, if you are electrician, which kind of connection you will give to the house? Series the parallel?
Parallel connection.
No, no,
Parallel.
Parallel connection.
no.
You will give parallel connection.
Parallel connection.
Series connection, when one goes off, everything will go off. Parallel connection, even if the one doesn't work. The same.
Parallel connection.
But can we have the wire? But can
Sorry?
we have the wiring branched in series connection so that if one goes out, that won't obstruct the current, the circuit?
Can we have branched in series? You mean
Yeah, like a separate wire for the bulb, like going out from the main wire.
separately you give a wire
Parallel
for
connection.
bulb, you give a wire for fan, that kind of connection.
Yes.
That is again parallel. No? In one single connection, if you connect everything, that's series. Now I know the question you're asking. From the same supply, you give the wire for the bulb, you give the wire for the fan, you give the wire for the bulb. This kind of connection, no?
Yes.
What is this? Parallel, no?
Parallel.
I have
Sure,
drawn the
I
same thing
understand.
here.
Yeah. I
See?
see.
You connect a wire there, stretch it. It's this. Okay.
Yes.
Sorry. Division box. Who is going to read?
Sir, can I?
Whose hand is risen? I'll go with the hand risen. Varshan, you can go ahead.
Sir, can I?
Yeah, Varshan, you can go ahead.
Distribution box. Electricity is distributed for consumption in the household through the distribution box. Electricity is distributed inside the house through lighting circuits and plug circuits. Adequate current to light bulbs in ordinary rooms is supplied by lighting circuits. The maximum current supplied to a lighting circuit is limited to 6 amperes. Plug circuits are connected to places such as kitchen that have devices like electric heaters and electric ovens that consume a large amount of electricity. Plug circuits allow the consumption of current up to about 13 amperes.
So here some topologies are given. You can use different topology. Bus topology is usually used for connecting in parallel connection. Who's going to read MCB? Whose hand is present? Ashley Henry. Is it your original name? I may come with your original name. Who is this Singh Jinwo? Michelle, can you read?
Miniature circuit breakers and fuse. Miniature circuit breakers supplying electricity are connected to each circuit inside the distribution box. When a current larger than the maximum current that can pass through the circuit is drawn, miniature circuit breakers automatically get disconnected and the lever shifts down to the off position. Because of this, the current electricity supply gets disconnected only in these circuits and not to the whole household. For lamp circuits, MCBs which can conduct a current of 6 ampere are used. For socket circuits, MCBs which can conduct a current of 13 ampere are used, while
Once again.
bulbs
Lamp circuits are light circuit. Socket circuits are plug circuits. Same thing. Keep reading.
While bulbs and two 6-ampere plugs can be connected to a lighting circuit, only plugs can be connected to plug circuits. Figure 10.11 shows the outward appearance of a fuse mount and a miniature circuit breaker.
Continue reading.
Thank you. MCBs can be mounted in specially designed distribution boxes. MCBs provide protection against electric shorts and resulting fire due to heated cables only. Since the fuse or the MCB does not operate when a person gets an electric shock, they do not provide any protection to people. In older domestic circuits, fuses were used instead of MCB. In lightning circuits, 5-ampere fuses were used instead of 6-ampere MCBs. Instead of 3-ampere MCBs, 15-ampere fuses were used. The use of fuses has declined because replacing fuse wires of blown fuses is inconvenient. When MCBs or fuses are connected, they must always be connected to the live wire. In modern domestic circuit, isolator RCCB and the distribution box are included in the same units called consumer unit.
So in your house, you would have seen isolator, trip switch, miniature circuit breaker, all are in the same box. That box is called consumer unit. Next switcher. Now if you look at a switch, you would have seen 3 plug points there. With your experience knowledge, tell me, what's the center middle one?
Earth.
That's the earth. Out of these two, one will be live, one will be neutral.
Neutral.
If you are connecting a fuse, to which one you are going to connect? Earth, the live, the neutral?
Live.
Live, you can connect a fuse. Why? Neutral, is there any potential?
No.
Zero potential. Earth function is totally different. It doesn't need a fuse. If you are connecting a fuse, you have to connect to a live. Switches and plug socket. Who is there next? Deshan, yeah, you can go ahead. If anyone else want to read, keep raising hand.
Switches and plug sockets. Switches used to turn on or off power electric bulbs are major components in domestic circuits. Switches are available as single units or as units consisting of several switches on the same board. The switches are connected to the circuit so as to enable the turning on or off of each bulb separately. Another important component in a domestic circuit is the plug socket. The live cable, the neutral cable, and the separately grounded earth cable are connected to the circuit elements. The larger terminal of a 3-pin plug socket is connected to the external metal cover of an electric appliance, and it connects to the earth wire in the domestic circuit when plugged on. This connection is essential in order to get protection from electric shocks by turning off the
1 minute, 1 minute. Why you need a earth wire? What's the use of a earth wire? Now let's take, you have a microwave oven. What is it? There is a wire in it, broke, it's leaking current to the metal casing there. It's leaking current to the metal casing there. If you go and touch it, yes, you can get current. You can get the shock. So to avoid it, have a trip switch. But additionally, what happens is, when you connect it to your plug point, your center plug is the earth. What does this earth do? That earth has a wire. That wire, a green color wire is there. That wire is really mounted to the earth. That wire is really mounted to the earth. It really goes under the earth. So when you are building your house, at a certain place, they will take a copper rod or a brass rod, insert it deep into the earth, connect a green color wire from that. That wire is given to all the center plug points in all your plug points. So when you connect your plugs to the plug point, the center plug point connects to that, which means now a wire from the electric appliance is connected to the earth plug point. From there, it's connected to the earth. Ehena, if there is an electrical leak, what will happen to that electrical leak? That electrical leak will come through the center wire, go directly to the earth. Why it goes to the earth? Because earth is usually considered as zero potential. Earth is zero potential. So here, if there is a high potential leak, from high potential to the earth, current will be sent. If it is sent like that, the shock will be high or low when we touch it.
Low.
Low.
Why? That leaking current is sent to the earth. So to protect you from leaking current only, you have a earth wire. That's why most of the metal case electric appliances have a earth. Now you all tell me, a plastic casing, does it need a earth?
No.
No.
That's
No.
why some plastic casings have 3 pins or 2 pins.
2.
Pins.
2 pins. Usually 3 pins come for the metal casing ones, or if there are any metal circuits inside, but low working capacity, plastic casing ones do not need earth. They are only 2 pins. That is the point given there. Another important component in domestic electric circuit is the plug socket. The live cable, the neutral cable, and the separately grounded earth cable are connected to this circuit element. The larger terminal of the 3-pin plug socket is connected to the external metal cover of the electric appliance and is connected to the earth wire in the domestic electric supply. This connection is essential in order to get protection from electric shocks by turning off the trip switch. For some of the modern electric equipment, having a plastic cover does not leak electricity. 2-pin plug can be used. 2-pin plug sockets are connected to the earth. Next, connecting wires. Copper wires with suitable cross-sectional areas are connected to the wires. Now, you all tell me, your lightning circuits are carrying 6 ampere current. Your plug circuits are carrying 13 ampere current. Which one should have a greater cross section? 13 ampere or 6 ampere?
6 ampere.
Greater cross section.
13 ampere.
13 ampere.
13 ampere should be high in cross section. Usually 13 ampere ones come with 1.5 millimeter square cross section. 6 ampere come with 1 millimeter square cross section. And we know live is there, neutral is there, earth is there. What are their colors? With experience, tell me. Live wire is
Brown.
live is brown. Neutral is
Blue.
blue. Earth is
green.
But in olden days, live was red, neutral was black. Earth is always green. Copper wires with suitable cross-sectional areas are used for connecting wires for carrying current. Single cable with 1 millimeter square cross-section area are used in order to carry 5 ampere, 6 ampere, while cable consisting of 7 wires with 1.5 millimeter effective cross-section area are used for 15 and 30. A brown PVC cover is used to identify live and blue for neutral. Previously, red and black covers are used to identify live and neutral respectively. Green covers are used for earth. Domestic electric circuit. Each bulb and each plug in the domestic circuit is connected in parallel to one another. All switches should be connected to the live. Therefore, touching a bulb circuit when the switch is in off position does not cause electric shock. Plug circuits are connected using cables that can withstand 13 ampere. Only plugs are connected to these circuits, and this type of circuits are often used in kitchens. Sometimes plug circuits are connected as ring circuits as well. Those are topologies. Ring circuits, they are bus topologies. Protection. Mainly we get protection from RCCB and MCB. RCCB protects us from what? Now your trip switch protects from what?
Shocks.
Current leak and resulting shocks. From fire, what protects?
MCB.
MCB. Again, I repeat, trip switch protects us from leakage and shocks. MCB protects us from fire. Is there any lightning protectors?
No.
Lightning protector. Residual current circuit breaker. In case of current leakage in electric appliances or in electric shock, RCCB disconnects the power supply to the whole house. In addition to this, RCCB also disconnects the power when a current greater than 30 ampere flows through the circuit. This prevents fire arising from overheated cables. Sometimes if a current more than 30 ampere comes also, RCCB will disconnect. MCB. These electrical components prevent large current flowing through domestic circuit. Fuses MCB do not provide protection from accident due to current leaks or electric shock. If there is a power disconnection due to any of the above reason, the overload circuit breaker should be open. Next, lever of the RCCB or MCB should be. Now let's take. You did some unnecessary work. MCB in the Dingala went down. Then what you do? Come and directly switch on the MCB. Nah, that's actually wrong. Even though we do that, that's actually wrong. What you have to do is, first you come out of the house. Why? Run. No. You come out of the house and you put your overload circuit breaker down. Out of the house. Overload circuit breaker down. And if you can put this is not much necessary. You can put your isolator and RCCB also down. It's not much necessary because already you are disconnected from outside. And if your whole MCB is down, you switch it on. Then you do everything in reverse. This up, then this up. You don't directly go and switch on the MCB. First this down, these two not highly necessary, but it's better if you want to disconnect live as well, neutral as well. You put these two down and switch it on, switch it on, switch it on, switch it on. In reverse you go. That's what is told there. Further to the above, it is very important to follow the following precautions. Only fuses appropriate for 6 ampere, 13 ampere current should be used. Many electric appliances that draw total current exceeding the capacity of the plug socket should be not connected to the plug socket through multi-plug. I already told you. The one multi-plug do not connect lot of appliances. Only plug suitable for plug socket should be inserted into the plug socket. Wires should not be inserted to a plug socket. Now when a mason boss comes to repair the house, a mason boss, I have never seen a mason boss who has plugs in his appliances. What is there? Direct wires. Boss, can I plug this? He takes the wire, plugs it in. Another 2 wire, plugs it in. Is it a correct practice? Is it correct to put the wire directly into the plug sockets? No. There should be plugs. It's a wrong practice. When using an electric iron for ironing clothes, rubber slippers or rubber carpet under the feet should be used. It is good to use a mat in front of refrigerator for safety. Now, when you're ironing clothes, before you iron, you quickly run out of the house. Take a rubber slipper, wear it and start ironing. Why? In case if there is a leak, that current should go to the earth through us. But if you are wearing a rubber slipper, can the current go to the earth? No. When there is a rubber slipper, current can't go to the earth. Tasks such as changing burned bulbs in bathroom should not be done without turning off overload circuit breaker or main switch. If you are changing the bulbs, especially in washrooms, you have to first switch off the overload circuit breaker. When electric appliances are not in use, their plug should be disconnected from the socket. Another wrong practice that we do. We switch off the TV from the remote, but we don't remove it from the plug point. Wrong. You switch it from the remote and you remove it from the plug point as well. If there are strong lightning strikes, radio receivers and television sets should be unplugged as much as possible. In such, it is advisable to refrain from using any unessential electric devices. RCCB do not protect the domestic circuit from thunder. So during thunder, you have to remove the radio receivers. Best is you put it outside the house and you disconnect all your TVs and radios. Electric devices should not be used when the body is wet. Electric switches should not be turned on or off with wet hands. During a power failure, switches of electric appliances should not be turned on. No, there is a power. I used to do this. We go and search all the switches and we switch it off. We switch on only one light and keep to check whether the current comes on. If power comes again, and then we go and switch on all the things. In case of a fire, the domestic power supply should be disconnected using the overload circuit breaker. So let's say your house catches fire. What you do first? You will tell, sir, we have to collect all the documents. We have to collect all the essential things. We have to take the medicinal things and run out. Nah, puta. If you are a science student, you have to quickly go and switch off the overload circuit breaker, not anything else. Right? So during a fire, you have to switch off the overload circuit breaker. All maintenance work and installing power extension should be done by trained electrician. Functioning of RCB should be checked every few days by pressing the test button. Ta-da! Last few three sections were just reading sections. Any doubts?
No, sir.
No, sir. No, sir.
No, no.
Sir,
Yeah, bata.
will we get to draw the electric circuits inside the house and stuff, those diagrams?
Not the full diagram. Maybe they will give parts and ask you. They might give the starting drawing of the live and the neutral. They will ask you to complete it. So you should know. Live goes inside overload circuit breaker, neutral doesn't go inside. Live and neutral both go inside isolator, RCCB, MCB. So maybe wires they might ask you to draw, not the full circuit.
Okay, sir. Thank you.
Okay. Yeah, bata.
Lots of electricity when distributing current to wire.
Loss when you are distributing from where to where?
Using cable.
Sorry?
Using cable.
Yeah, there's
To
a
the
big loss. There's a big loss. There is a big loss. Now from national power grid to your house, big loss is there. To avoid that loss only, you supply it at a high voltage. How that loss is reduced by increasing voltage, that connection I will teach you all in electromagnetic induction lesson. So I will teach why you increase the voltage to 220 watt, 132 kilowatt, 220 kilowatt, 132 kilowatt. There is a loss. You can overcome that loss due to that high potential. Okay, no? Hurry now. Power and energy is done. And this month there will be a free session. There will be a free session. I posted in the main channel what you all want. Most of you all have asked for essay question discussion. So I will be scheduling essay question discussion. That also most of you have asked on Friday. I'll be scheduling essay question discussion. We'll be discussing essay question. That free session is there upcoming for grade 11s. That's the plan for grade 11s. Plus new updates. Tomorrow, no class at Gaul. 10th and 11th. I already informed you all. I have my exams tomorrow. And it's in the evening, so I can't do the Gaul class. So tomorrow, no class for Gaul students. Other than that, all the other places classes will take place as usual. Hurry, Nathan. Hurry, now. Thank you and God bless you. Keep studying. I'll meet you all again in my next session.
Thank you, sir.
Thank you very much, sir. Bye.
Thank you, sir.
Good night.